Yeah, so we are live streaming, and we're actually live streaming on the following three pages: YPS, Young Professional Society, also STEM Matters, and Nanosmart Global. Okay, very good evening to everyone. My name is Dr. Nasir Ali, and I would like to welcome everyone to this webinar. These webinars are organized by YPS, Young Professional Society, also Nanosmart Global, and our collaborator STEM Matters, who are based in Texas in the United States. Our Young Professional Society was set up to help young people with personal and professional development. And we do that by focusing on three areas: communication, leadership, and innovation. So YPS places a great focus on innovation as it's one of our three pillars. And we regularly organize webinars to help young people learn about leadership, to learn about innovation. And we do that by inviting prominent professionals from all around the world. And STEM Matters are also doing an excellent job in helping to teach and train youngsters in STEM. And today we're delighted to have with us a very prominent person, Dr. Mikael Syväjärvi from Sweden, who is an academic. He's a researcher, a scientist, innovator, and a technology transfer expert. Now, this will be a general conversation with Mikael to ask him about the work he's involved with, and in particular on innovation. But before we do that, I would like to give you a brief introduction to Mikael. Dr. Mikael Syväjärvi is a researcher, an academic, an innovator, and technology transfer expert. Mikael has worked as an academic for many years at Linköping University in Sweden in the physics department. He's currently the managing director of Alminica, a technology transfer company based in Sweden. The company was founded in 2016, 5 years ago, by Mikael himself to build innovation capacity in advanced materials research and innovation. Dr. Mikael is a materials researcher since 1995 in energy and environmental materials. Since 2005, he has been active with creating utilization from research, for example, forming startup companies, technology transfer. His overall aim is to create more usefulness from research findings and in such way contribute to minimize climate crisis, energy savings need, environmental savings, and such globally relevant sustainability issues. So I would like to thank Dr. Mikael Syväjärvi for his time, and I would like to welcome him. Now, let me begin by asking Mikael, what inspired you and who motivated you to do a PhD? And why did you choose to study materials at PhD level?
Yes, so thank you very much, Nasar, for inviting me to this opportunity to share some experiences and so on. And I will talk a little bit about innovation and also how it came to this level where I am now. It is partly dependent on that I made a PhD in materials. And if I go back a few years before that one, when I was a young kid at high school, then I did not know what I would like to be or what was my main interest. And I come from a handicraft family. My father is a carpenter, and somehow I decided that I will study natural science at the high school. And then when I still did not know what I would like to do in my life, then I found a university program which was very flexible. You study some basic courses, and then you select in the fourth year. And over this time, I felt more and more materials is what I'm interested in, and so on. And then just followed that path. And when it was time to make a master thesis, the diploma thesis to finish my program, then I did it in a group in semiconductor materials. And then they happened to have a position where they needed help in a project where it was silicon carbide growth in microgravity. So it was really cool project because it was an experiment on a sounding rocket, and it went up, and then it was 7 minutes of microgravity. So that was my first involvement. And then I enrolled to the PhD studies at that time because I was thinking, if I anyway do these experiments, if I do this research, I can anyway write some papers. So I just gradually came into the PhD studies. It was not an intention that I wanted to have a PhD for a particular reason. I just followed my interest, and then it was the materials which was my genuine interest. And I'm not that smart that I can understand things and calculate, but I have a feeling in the lab, which I follow. So maybe this comes from my handicraft tradition in the family and so on. So that's how I came into the making the PhDs and into the materials.
Yes, it's interesting you mentioned that, the handicraft thing, because I remember the late Nobel Prize, Sir Harold Kroto, who got the Nobel Prize for discovering C60. When Harry used to give presentations, he used to always mention about his love for art, and he was good at art. However, he said that when he was at school, he was also sort of happened to be good at chemistry as well, and he ended up getting the Nobel Prize. But even to his sort of later years, he was still be in touch with the art. So it's a good combination to have some art with some scientific or materials sort of research interest as well. So that's great. Now, doing a PhD is about introducing new knowledge or making an original contribution to knowledge. What was the prime novelty of your PhD project?
That was actually the PhD topic was making this silicon carbide for power devices. So when you want to convert like 10,000 volt in the energy system, then you need certain materials which are suitable for that. So then I developed, in the team, we developed a method for making thick layers which are, or could be suitable for that. It was a novel idea, but it didn't work out because these layers were not useful for the power devices. So the novelty was not a novelty. But later on, there came a Japanese researcher who were interested in thick layers of silicon carbide, because when you add some elements to it, it can be a light-emitting material. So then we suddenly came from the power devices to LEDs. And then it became really novel because it was a new research area and very nice collaboration with Mayo University. And this guy, Satoshi Kamiyama, he comes from the group where they got the Nobel Prize for the blue LED. So then suddenly, due to some happenings and interest and that we made this met at some point, then we shifted. So that became the real novelty of my PhD thesis, but it was not a part of the plan from the beginning. But with this, I would like to illustrate that whatever we do, when we start something, we might have a good idea and then we move ahead and then things change. So even though they don't work out at the time when we hope they will work out, then they are very useful later on in some way.
Yeah, so I'm sure there was a lot of novel work that you're involved with during your PhD. So as a student at the time, were you sort of more interested in sort of writing research papers for publication? Because obviously, PhD students, once they start, they want to see their names appear in papers and papers appearing in journals. Or were you also sort of thinking along the lines where, okay, this is novel, maybe we could sort of even spin out a company or with the help of your supervisor? Or was it more sort of for research publications?
From the beginning, it was publications, and I was very deep into the physics and atoms and studying defects in the material, and then we tried to understand how they did appear, and then we wrote papers about it. So that was deeply curiosity in the materials physics. And then later on, actually, I remember it was in 2005, I was sitting in the cantina, we had lunch, and there were a few people around the table. And then one person who was visiting, she was working with technology transfer. And then when I happened to describe the method which we have had, then she thought it was interesting. And then I was starting to think, yes, maybe it is interesting. Maybe we can think of making usefulness from the research findings. And that's when I started to think about how to make usefulness from research findings. And then it became a motivation, not only to write papers, because papers are nice, but actually to see something in practice that they will be used in a technology which I have been part of creating. So it transformed from this deep science, curiosity, interest to the innovation and usefulness in a natural way.
And also, I think you also depends on your PhD supervisor as well, whether he's trying to sort of encourage you to sort of think about spinning out companies on innovation, or just to sort of do the work, get the project over and done with, write some papers, get some publications, and that. It's also important, I think, that PhD supervisors can play an important role in sort of guiding PhD students.
Yeah, so those are good things. In my case, it was not any encouragement particularly, but I remember that I started to go to these patent courses and some smaller things just to learn a little more. And then I learned a little more and a little more. And then actually at some point, one guy from the innovations office, he noted that there were 4 researchers who were in initial stage of being entrepreneurs. So he put together us, and then we met every 3 months and discussed a little bit, and sometimes there was invited lecture. So in my case, the innovation office guy, he encouraged much more because he was very welcome. Oh, you're interested? Ah, come in here and listen to these things and so on. So it was not part of the supervisor. But at the same time, in my case, the supervisors and the seniors in the division, when there was a spin-off activity, or later on when we made a graphene company, they encouraged that one and had the understanding that there's a balance of the research and this usefulness. So in some way they combine.
And now after PhD, people either sort of continue with research in academia, or they would like to sort of go to industry. What would you say are the pros and cons of going either way?
Both can be like good and bad, because now it's challenging to be in academia because it's very difficult to get research funding. But also in industry, it's very insecure situation. If you go and be employed somewhere, you can be fired next day if the industry decides for that. So I think neither way is preferred. You should, if I would encourage a student or younger generation, is that follow the path you believe in, because then you will meet people, and in some way you will create opportunities. So if you happen to meet more academic partners, then maybe follow that one and create opportunities. And if you meet more industry people, then it's that will be opportunity. So both have the pros and cons. But at the end, it is people who work together. The technologies will not go to the market themselves. It's by people meeting other people and networks. And in my case, I have experiences from both. Like 2010, I had a research project in this silicon carbide for LEDs. And then I found a couple of partners for a project. There was a call. And with them, I have been working together since that time. So after this initial first project, we got other ones and other ones. And in some way, our careers and interests, they were aligned. They were like synergetic without that being a plan. So when you find some matching interest from people, it's better to follow those. either it's academic or industrial, and first of all to listen to your own interest, what you would like to do. And it will shift over time, because over 30, 40 years, then things will shift in some ways.
And it's generally sort of understood or accepted that, if you want to make money, you go to industry. If you don't want to make so much money and you have a bit more flexibility, go to academia.
Yeah, so it's always those things. And like in my case, I prefer to stay in academia because I had family situation. Since I have like 4 kids, family has always been important, that they have the first priority, and then I work later. So I pick them up at daycare and such things, so I can be with them. And then when I became more interested in industrial activities, then I preferred this small startup company environment, because then we still decide what we would like to do. It is very challenging, but if being in a big industry, then you're part of a chain, then one cannot influence as much, and then you have to follow the rules much more, because they are more established in those industries.
Yeah, so we will have some youngsters who are watching this conversation. For their sake, although nanotechnology has been going now for some decades, still new applications are emerging all the time. For the sake of the youth, for the young people, how important is nanotechnology and what potentials does it hold?
Yeah, nanotechnology, because this is a concept which is very broad. You can have nano size things in medicine, in technology, in many things, and then you can combine so it becomes many branches. So that makes it challenging, but it's also an opportunity, because once you have some findings, you can explore them, and at some point maybe they will be useful in another area due to the nano size. And whatever we do, from big materials, big electronics, we want to make things smaller, because then it becomes more efficient, but we can also save energy. So understanding the things on the nano size, then we can have, there will be technologies and things which will outcompete the traditional ones. So nanotechnology is very fascinating, because it's so broad, so it's totally confusing. But once we find a particular area where we are interested, we can follow that one, and then wherever it goes.
Yeah, and it's interesting you mentioned that nanotechnology being very broad. And because it's broad, it's bringing people from different disciplines together to work together. So, for example, you have chemists working with biologists, physicists, who come together, work together to overcome some of the challenges that we face in the world today. So it's good in that sense. Now, what about innovation? What is innovation, and what is technology-driven innovation?
Yeah, basically for me, if I simplify it, then it's curiosity. When we want to explore something new, we might not know that it's an innovation, or what it will become useful in some way, and maybe somewhere where we did not believe in the first place. But if we know, for example, that we would like to push technologies further by new findings, so then that drive of the technology interest pushes things to make new things. And it's very interesting that you said meeting people from the other disciplines and so on, because if we only, like in my case, if I would only talk with material scientists or people from the physics, I would not get the broader perspective. If I meet other people who talk about some things, I can have the learnings from there and maybe combine in some new way. So that's why I think also this example of Professor Crotto, I heard one of his lectures once many years ago, that if you have other inspirations. It may be art and these things. It creates energy, but it also gives you some other way of thinking on things. And in some way, the brain works, and then it adapts to something which will become an innovative step. You can take things which you have done before, and in some way you just test it, and then it becomes some innovative step. So, and basically that is curiosity. We should try things, and when we failed, we learn from those things.
Yes, and it's interesting because some of these sort of discoveries happen accidentally as well. I mean, you mentioned Professor Kroto, and even Professor Kroto, when he was looking at some black graphite, black powder, he discovered C60. You know, C60. It wasn't some. So sometimes these discoveries, innovations can happen accidentally. But it's important that you sort of research and investigate. And it was Albert Einstein who said that it wouldn't be called research if we knew what we were doing. So, okay, so what challenges and hurdles do nanotechnologies face in overcoming some of the key challenges that the world is facing, such as fighting climate change, overcoming global warming, even developing vaccines for pandemics? You know, we're seeing at the moment with this COVID-19, curing cancer, and how to overcome these challenges?
Yeah, the challenge is that when everything is so new and we're still in the research phase, we might do discoveries, which are nice, but if they would ever be useful, then they need to be reproducible and possible to do in production. So one of the biggest challenges is not only nanotechnology, it's in many things, is how to take these findings and get them to be useful on a market. And whatever we do, people will compare costs. What is the cost of these things compared to the traditional ones, silicon, for example? And of course, since we are always in the early stage, the costs are very high. They only go down when you start to have volume production, high volume production. So then that is a challenge, how to motivate that someone will actually fund this, because everyone will compare with traditional material, silicon usually, and so on. But this is also the fascinating thing, because once we explore these properties and technologies, there will be a certain niche where this is something is super unique, and then nothing else can compete with, for example, the nanotechnology innovation in that particular niche. In other areas, it's not useful, but here it outcompetes. So that is also the inspiration why we should continue do the things we believe in, because we move ahead, and then at some point there would be an opportunity for this particular niche thing.
And also, you know, you mentioned people, scientists working in laboratories and that. And however, sometimes there are issues with funding as well. So the capability is there, people are there to sort of conduct, but because there's lack of funding, they're not able to sort of complete their studies, the work, the investigation, and as a result, people are not able to sort of bring these out to the market and materialize the findings. And also sometimes what happens is that the scientists are working the lab scale, not knowing what's needed out there in the market to commercialize. So maybe there needs to sort of form an alliance between those people in the market and the scientists to understand what is needed. And with the better sort of communication, they should be able to sort of deliver. But yeah, funding is one of the issues, and a lot of the academics would sort of understand that with the funding limitations. And if that is done, then hopefully, you know, more projects could go to completion and people will benefit from the finding.
Yes. Yeah. The good thing about having not sufficient amount of funding is that then we always need to be at the edge. So we keep on thinking, okay, what is next? What can I propose to take this to the next level? So we don't continue in the same path, but we have a little bit of inspiration to move to other avenues in some way. So that's the part of the good and bad with having not sufficient amount of fundings. But there are certainly more, we should have more interaction so we understand what problems are out there with the industry or in the region. So then we can actually maybe focus some of our competences and towards real problems instead of doing research and then trying to find the problem. So the earlier we are in contact and network with other people, industry, but it can also be politicians. So we understand how a technology could fit in a larger context. For example, the regional growth, because the technology should be used somewhere, and this is in a larger context like the region. And over time, this is very good motivation how to over time go to the UN goals, the 2030 goals, which are very broad. But if we start to find regionally how this is relevant and then building it up, we will reach those goals and make a contribution.
Yeah. Now, innovation, it needs to start early on. How should innovation be introduced and encouraged in schools so kids at a young age are able to sort of know and understand what innovation is?
Yeah, basically, like I said before, keeping this curiosity that people, kids, and everyone dares to do things and not seeing a failure as a bad thing. Because if we test something, then we learn from that. So basically encouraging the curiosity and doing things that will lead over time to something which will be then called like innovation or some other discovery type of process. So that is the general thing about how to encourage in school. It's to encourage the kids to continue and follow their interest and try things.
Okay, so at the moment you're working from for your company Alminica, which is based in Sweden, which focuses on innovation. Can you give one or two examples of projects that you're involved with in Alminica?
Yes, so I felt this shift from my deep science when I wrote all those papers and so on, and then I had possibility of making a technology transfer, and then we made a startup company in graphene and so on. So I felt this shift that I'm moving towards how to make more usefulness in other contexts than in the research. So then I actually decided that I will form my own company, because then I can participate with that one and then shift from the research to my company activity, which is basically looking into the research, but from the utilization point of view. So not the research point of view, but the other side. So then I've been having that shift. And then now one of the first projects, big projects where my company is involved and where it is active with the innovation and technology transfer, how to consider those things in broader context. This is actually the researchers I mentioned that I started to collaborate with 2010. One of them had an idea of using silicon carbide for a so-called frequency comb. For example, if you have a laser, it has the laser light with certain wavelength, and then you can send information. So this is communication. And like in servers and so on, when you want to communicate, you can have 64 lasers sending information. A frequency comb is when you have a material which takes a signal and splits it to many lines. For example, if you can have one material splitting into 64 wavelengths, then it can communicate. So instead of having 64 lasers using all the power and so on and a lot of energy, you can do it in one material. And this European project is so-called EU FET Open, which means that it's a radical research which has the possibility to make technology leaps, so long leaps and so on. And there, my involvement was not the silicon carbide technology and the growth of the material. It's on this innovation aspect. So then it became an added value that my company was a partner in the EU project. And since I have experience from things in Europe, how on smart specialization, research and innovation for smart specialization, which is about making more regional economic growth. And if we have interactions between the technology and the smart specialization, there will be synergies. So that's one of the projects where I came into half year ago. That project started in October, and it's very exciting because it's no one else in the world has been doing these things in a similar way from silicon carbide.
Okay, how do you see the prospects of new technologies, emerging technologies, which have interesting approaches, but in fact have not yet shown that these can make it to the market and really contribute to the sustainability? There are many uncertainties along the way.
Yes, those are one of the challenging things for the future. So for example, now we have our expertise areas and some traditional collaborations. But if we are looking into new concepts, if we have more exchange with people from other parts of the world, for example, this type of innovation webinars or exchange, which we can do online, then we can do them more often than in a conference and so on. And if we can interact with other researchers, entrepreneurs, innovators, we will find matchings for new technologies, which are very good ideas based on some physics, for example, but then we have to realize them. And this we can do together by using our competencies in these things. So actually, the second example of Alminica is that I do this from my home. So I support these concepts from home. We don't need to have the physical meeting, and I don't need to have a lab for technology development. So this concept of digitalization, and since I live on the countryside, maybe I can facilitate that there is more economic growth on the countryside because I decide to work from my home. This is behind my background here. I have my room and all my guitars. So then I can facilitate and work internationally. Earlier today, I had a seminar exchange with India, and then I was sitting here also, and we were discussing things, and in such way, when we are more open and discuss things, then we can come into these new technologies and other avenues which can be super exciting. They might fail, but then we are building learnings, and they will be useful in some other ways. So this is the technology for future, which I think we can do more of if we have more exchange in conferences, but also online and in other ways. And discussions like this, then we are sharing information very informally, and maybe something will pop up that there was an idea. Either if you hear about it, or some other listeners or young people, they will pick it up and think it's interesting, and they will utilize this for something next.
Yeah, and collaboration, as you mentioned, is very, very important. And now, obviously, being in this COVID era, being able to sort of use technologies like this on Zoom and communicating our ideas. And you mentioned you had a meeting earlier with India discussing about different ideas. So international collaboration is very important, and you seem to have a very broad um, international network. How did you manage to build this broad and very strong international network, which consists of scientists and other key influential people working in the education and the technology sector?
Yeah, this is quite naturally. With age, you get more friends, but also when I've been, I have always been going to conferences. I remember when I was a PhD student, I asked supervisors, "Can I get money to go to this conference?" And then I also applied for scholarships, so then I could go to several conferences per year because I managed to get them. And there, I think I understood that this interaction is very useful to understand more of the knowledge and what are there, but also you make relations. And after some time, when you come to a next conference, then you will meet someone. Oh, we were sitting at the same table and discussing music and guitars. And then when we continue discussion, we will find that in some way, our experiences are matching now. And then we come to a project. So such thing I have been always trying to do. And you know, like in Sweden, we also drink a lot of coffee. So there we discuss these things also. So to build a network from your personal relations in some way is, and now after quite many years, 25 years in the research, I have got several contact points and friends and so on. So they grow over time. And if we are nice in this world and being nice to each other and so on, good friends will get other good friends, and then it accumulates and so on. But also I believe in, if you're a nice person and open and discussing things, there will be more expansion of the networks which we have. So this is something which, if I would encourage the younger generation, is to be curious, talk with people. If you have a question about something, go and knock on the door for the professor and ask about these things. Don't be shy. And then I know that many of those professors, and they actually appreciate that someone comes and asks, because it's not often that someone comes and knocks on the door and asks about these things. So that's very much encouraged to do for building the network and opportunities and so on.
And there will be an opportunity for everyone to ask Mikael some questions, because Mikael will be one of the invited speakers at the YPS conference, which will be held on the 25th of September this year in Manchester, in the UK. Hopefully everything will be back to sort of normal. So all the youngsters and senior people who are interested in what Mikael is doing and want to ask him any questions, then you're more than welcome to take this opportunity to see him in Manchester in September, and hopefully maybe, you know, something will come out of this, and maybe a new collaboration on a new project. So please do take note of that. 25th of September in Manchester, the YPS conference. You can actually see the YPS website. So that's www.ypsociety.uk, and you can find more information about the conference. So I think we have gone over our time. I was thinking that we'll speak for about half an hour or so. So I think it's been about 40 minutes, and it's probably getting a bit late in Sweden as well. But just to wrap up, before we leave, I would like to ask you, what message would you give to the young people who want to make a contribution in innovation?
If it's innovation or whatever, playing rock and roll music or whatever you're interested in, to follow that path. I remember when I was young, and when it became, when we were to select program for high school and so on, then people were calculating, oh, in this and this area, IT or whatever, there will be many jobs 3 years from now when you graduate. But it was never the truth that it were many jobs. But I have always found job and interesting things to do when following your own interest. And also team up with people, so you find friends, because it will be hard times. But if you are too free, working together, you can do much more than only being one person. So I had this experience from some when we had work to be done. Instead of having one salary for one person, we had this one salary divided on 3 persons. One was responsible and 2 supported. And then we could sort of get the 130% work to be done because we could interact and we could balance availability. So team up is something. Believe in yourself, team up, and then move ahead. So these are 2 basic recommendations from me.
Okay, thank you very much, Mikael, once again for your time and for speaking with us, and hopefully a lot of the youngsters, young people who have been listening will find this very beneficial and very useful. And those people who were watching this live stream on Facebook, thank you very much for your time. And Mikael, once again, thank you very much and good night to everyone. Thank you.
Yes, thank you and good night.